Alright, for today's lesson, we're going to be finding the GCF, which you might remember from previous grades. The GCF is just the greatest common factor. So we're going to do that first by identifying all the terms of the expression that we're given. Then we're going to factor the coefficient of each term using a factor tree. And we'll look at the variable portion and then write the greatest common factor. So first for number 1 here, I'm going to factor the coefficients. So 4 I factor as 2 times 2, and 6 I factor as 3 times 2. I see both have a 2 and nothing else. They don't have anything else in common. So 2 is going to be part of my GCF. Now I'm going to look at the variables. So I see that n to the 7th is in one term. This is the same as n times itself, 7 times. I can group 5 of those together, right, if I'm canceling these out. So 1, 2, 3, 4, 5. That's the same as n to the 5th, right? N times itself 5 times. Okay, and then I have 2 left, so this would be n squared. So this tells me that n to the 7th has n to the 5th in it. And I have an n to the 5th in my second term here. So they both have an n to the 5th in common. So that's going to be part of my GCF. Part of my greatest common factor. Okay, so that's my final answer there. This means that I could factor out a 2n to the 5th from both of these terms. And that's the biggest thing that I could factor out. Okay, so moving on to number 2 now. If I factor, and when it asks you just to identify the GCF, this is all you would put as your answer. Okay, so moving on to number 2 now. I'm going to factor these, so 12 factors as 6 times 2, this is just 2 times 3. 21 is 3 times 7, and I can't factor that anymore. 6 is 2 times 3. So I see they all have a 3 in common. And they all have something else in common too, actually. Oh, I'm sorry. No, the first term and the last term have a 2 in common, but it's not in the middle. So 3 is the biggest term that the coefficients have in common. Okay, so that'll be part of our GCF. Now we're going to look at the variables. So I have v squared, and v cubed. Okay, so the biggest thing that the variables all have in common is a single v. Okay, so that's going to be my greatest common factor here. Again, when you're looking for the greatest common factor, you're just looking at the last number in these factor trees. So the factors of 12, I would say 2, 3, 2, and then 3 and 7, and 2 and 3. Okay, so you're not going to look at that 6 once you factor it. Okay, so that's how you get the number. And then for the variables, if you wanted to think of it like factoring these, this is kind of what your tree would look like, right? But I can't really do anything with that first v. It's just by itself, so that's the biggest thing that they have in common. Alright, so I'm going to go ahead and factor these now. So number 3, 12 factors to 2 and 6, and then 6 is 3 times 2, 15 is 5 times 3, so I see that the biggest number there is 3. Looking at the variables, the 12 has a p with it, but the 15 doesn't, so that variable isn't included for the GCF. Okay, number 4, here I'm going to have the 3m. 3 I can't really factor at all, that's just like 1 times 3. And the 6 is like 2 times 3, so they both have a 3 in common. And then this has 1m and this has 2, so my answer is going to be 3m. Okay. That's the biggest thing that I could factor out of both of those terms. Okay, next examples. Let's factoring these. I get 5 times 2, 5 times 6, which goes to 3 times 2, 3 times 10, which goes to 5 and 2. I notice they all have a 2 in common, but they also all have a 5 in common. Okay, that means they all have 2 times 5 in their factorings. We call this the prime factorization, actually, when we go all the way down. So they all have 2 times 5, which means they really all have a 10. Looking at the numbers, you can see that easily, right? 10 times 3 is 30, and 10 times 1 is 10. So there's definitely a 10 within each of those terms. Now, looking at the variable, I know I'm going to have x because they all have an x. Now I want to know how many do I have. So what's the exponent that I should have here? I see I have x to the third, x to the sixth, and x to the fourth. So they all have at least an x cubed, right? I can't take any, but that's the biggest that I could also take from all of them, right? Because if I try to take an x to the fourth out of the first term, it would be too many. Okay, and again, I could expand these to look at that. So x to the sixth looks like this. There's 6 x's being multiplied to each other, right? X to the fourth, and then x cubed. So I'm looking for what they all have in common, which would be those 3 x's. So x cubed is included in the GCF. Okay, moving on to number 6, I'm going to factor these. There's more than one way to factor it, but the final thing is going to get you the same answer. So factoring this down to primes, I have 3 2's and 1 3 for 24. I have 1 2 and 2 3's for 18. Then a 2, a 3, and a 7 for 42. So I'm looking for what do all of these have. Okay, I see they all have a 2 and a 3. And there's nothing else that I could take out of these, okay? Some have another 2, some have another 3, the last one has another 7, but it's not common to all 3. So the 2 and the 3 are the only things that are common. So I'm going to multiply those together, and I'll get 6. And then looking at the variables, I can take out an a squared. Okay, so that would be my GCF for number 6. Alright, and then in class we talked about what we learned, how we learned it, how it fits into mathematics, and a little bit of how we might use this in real life. Okay, that's it for today's lesson. Thank you.